Welcome back to the deep dive. Today, we're jumping straight into object-oriented programming.
OOP.
Yep. Specifically looking at it through the lens of Python.
Exactly. This isn't just a vocabulary lesson.
Yeah.
We want to get you comfortable with the paradigm that, well, pretty much drives modern software development.
Mhm.
We've sifted through some excellent material, and our goal really is to give you the fast track. Understand OOP in Python without getting buried in jargon.
Sounds good.
So the absolute core idea, OOP asks us to think differently. Not just lines of code, but entities, things.
Right. And we use classes and objects for that.
Okay, so what does that actually look like in practice? Give us the classic analogy.
The cookie cutter one. It holds up. Think of a class like that metal cookie cutter. It defines the cookie, right?
That defines it how?
Well, it sets the potential properties like color, shape, maybe texture. And the behavior is what you can do with a cookie. Dip it in milk, chew it, bite it.
But it's just the outline, the potential.
Exactly. Just the template, the object. That's the actual cookie you bake using the cutter. So the specific cookie, maybe a red, chewy, star-shaped one.
Or a green Christie circle.
Mhm.
Each one baked is a unique instance of the cookie class. They follow the blueprint, but have their own specifics.
Okay, template versus instance. That makes sense. That's where things like memory and behavior start to matter, right?
Precisely.
Yeah.
And once you have these building blocks, these objects, you need rules for putting them in together. Structure.
Which brings us to the big four, the pillars of OOP.
Right. These are the principles that make OOP more than just, tidying up code. They enable scale and maintainability.
Okay, lay them out for us.
First up, abstraction. This one's key for handling complexity.
Hiding the messy details.
Pretty much. You expose only what's necessary and hide the complex implementation stuff. Like when you sort a list in Python using .sort.
Yeah.
You don't need the nitty-gritty of how Python sorts it. Is it timsort? Quicksort? Doesn't matter for using it. You just trust it'll get sorted. That's abstraction.
Okay, hiding the how. Got it. What's next?
It's close cousin. Encapsulation. People sometimes mix these up.
How are they different then?
Abstraction hides complexity. Encapsulation is about bundling the data, the attributes, and the methods that work on that data together within the object.
Bundling and protecting.
Exactly. Controlling access, you define clear interfaces. In Python, this is often done by convention, not strict enforcement like in some other languages.
You mean the underscores?
Like salary.
Yep, those double underscores or dunder underscores. It's a signal basically saying, hey, this is internal data. Use the object's methods to interact with it. Don't mess with it directly.
Keeps the object's internal state consistent. It's more of a guideline, though.
It is. A strong convention, a social contract among developers. But yeah, not a hard lock. Okay, moving on to reuse. Inheritance.
The family tree idea. Passing things down.
Right. A new class, the child, can inherit properties and behaviors from an existing class, the parent.
This is where don't repeat yourself, DRY, really comes into play, isn't it?
Absolutely. If you have a vehicle class with a start engine method,
Your car class and truck class, just inherit it. No need to write it twice. Exactly. Saves a ton of work. But Python allows inheriting from multiple parents.
multiple inheritance. I've heard that can get complicated.
It can. That's where you bump into something called method resolution order, or MRO.
MRO. Okay, what's that?
It's the specific algorithm Python uses, C3 linearization, technically, to figure out which parent's method to use if there's an overlap or a complex hierarchy.
So the order matters a lot.
Critically, if you're building complex systems, you have to understand how Python decides the MRO. Otherwise, you get unexpected behavior. Using super correctly is also tied into this.
Right. Super helps you call the parent method properly within that hierarchy. So it's not just that inheritance exists, but the mechanics of how Python handles it.
Precisely. Okay, fourth pillar, polymorphism.
Literally many forms.
Yep. And in Python, this is often linked to something called duck typing.
If it walks like a duck and quacks like a duck.
Python treats it like a duck. It doesn't strictly care about the object's class type. It cares if the object can do what you're asking it to do. Does it have the method you're trying to call?
So less focus on strict types, more on capabilities.
Exactly. Very flexible. And you also see polymorphism with operator overloading.
Like the plus sign plus way.
Perfect example. Add two numbers, 1 plus 2, you get arithmetic addition, 3.
Add two strings, A plus B, you get concatenation, AB.
Same operator plus error. Different behavior depending on the objects it's working with. That's polymorphism. Classes implement this using special dunder methods, like add.
Okay, abstraction, encapsulation, inheritance, polymorphism. These four are the bedrock.
They really are. They're why OOP helps you code faster, build bigger things,
Mhm.
and avoid that horrible spaghetti code situation.
Yeah,